Yeah.
It's 6.3.
Yeah, Rude's back in town.
Oh, geez. Here we go.
All right, sigma notation. Sigma is Greek, and we're going to use it in notation.
Greek. Was Santa Greek?
Boys and girls, just bear with me.
There we go. 2, 4, 6, 8, 10, 12. Turns into 2 plus 4 plus 6 plus 8 plus 10 plus 12?
Correct. We're going to be adding up our sequences today.
Oh.
So if I had this sequence right here, if we added it up, we would get 42. So right now, you're going to pause your video and you're going to write this down because this is sigma notation. This giant letter right here is the Greek letter sigma. This is what it looks capital, and this is what it looks in lowercase. We'll use lowercase when we do statistics, but we call it the big E sometimes.
Okay, so you're pausing this right now, or you're going to let this play, you know, as if we were on Jeopardy. That's good enough. All right, here we go.
All right, so we've got 3 sections to this. The letter that is above the sigma tells us where our sequence is going to end.
But where do we begin?
And right down here, this tells us where to begin.
So we're going to go from bottom to top.
The formula that we're going to follow will be written to the right, and then we're going to add up all our terms, because this beginning and end tells us to start at term 1 and end at some term.
And this symbol, this Greek symbol, or the big E, means sum up everything you see according to the values you plugged into the function, which here we're calling A.
All right, so all that is Greek to you. Ha ha! Here we go.
That was a good one.
So we have this formula right here. All right?
I know where to start. It's on the bottom. Starting at 1, I'm going to go to 7, so I'm going to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Right, Miss Truland?
Almost. Remember, this is the formula we're going to have to follow.
Oh, yeah, the function.
So we're going to start by putting 1 in for k, and we get 1 plus 5, which is 6.
Okay. Then we're going to plug a 2 in. So 2 plus 5 is just a 7. And we're going to continue this all the way until you end at the value that was on top of that Greek symbol. So right now we're plugging in 3, then 4, then 5, then 6, concluding with 7.
All right, so get it? So here's where we started, and we had to keep going all the way, running out of room until we got to the 7.
So our first digit was the k in the function, so that's the number you're plugging in. That's why it says on the bottom of that Greek symbol, it says k equals 1.
So we're just plugging it in there. So my numbers are 6, 7, 8, 9, 10, 11, and 12. And what do they want me to do with those numbers?
Add them up.
That's what the sigma means. It means add them all up.
Summation value.
So if I were to add them all up, now I'm going to use my little shortcut, my Gaussian shortcut.
I think it's Gaussian, Miss Truland. Gaussian.
I like Gaussian.
Okay.
6 and 12 is 18. 7 and 11 is 18. 8 and 10 is 18. So I have 18 3 times. And then little old 9 didn't have anybody to pair with. So the sum of all this
is 63.
All right, so if I were to erase all that, I would say the sum of all this equals 63.
I really like the background, Miss Truland. Those snowflakes make me really into this holiday spirit.
For those of you who don't know, that's called sarcasm and mockery.
It's just rude.
Oh, this gets better by the minute.
Here we go.
All right.
Example 2. Using sigma notation, find the sum of the first 25 positive integers. Does positive really have any key significance here?
No, because it tells us to start at 1, so that's positive, and go all the way to 25.
Oh. Therefore, if I count on my fingers, 1, 2, 3, 4, all the way up to 25, I do know that I'm positive. And my value n represents the function here. So that just means you're plugging numbers in and just kind of adding them up, you're not really doing anything to them. Like the last example, we added something to it before we added all the terms up. What do we do here?
Nothing. That's why if you saw when I hit it real quick because it was still out there, this is what it would look like. You would see that we're going to start at 1. We're going to go all the way to 25. And sigma means to add up those numbers all together.
Oh, so this is another shortcut. Gaussian shortcut.
Yes,
Here we go.
it can be. So, let's see what we get. When we take the first and we pair it with the last, we get 26. And 2 plus 24 gets me 26. Well, how many pairs of 26 are we going to have? Well, an easy way to do it, instead of drawing all these arcs and running out of room, was 25 divided by 2 gives me 12 and a half pairs of numbers. And each pair is worth?
26.
So I'm going to take 12 and a half pairs and times that by 26. Would you like to do that for me, Mr. Rude?
Sure. Let's figure this out. 12.5 times 26. If I was to do this out, I would be getting, let me just add this and carry the 1 and carry the 2. No, carry the 2. Yep, 325 is confirmed. 325.
Yay!
That was pretty easy.
Use sigma notation to find the sum of the first 25 positive odd integers.
Wasn't that the same thing we just did in the last example?
No, that was just the first 25 positive integers.
Oh, so we're going to cut it in half by saying it's odd?
Well, we got to do the odd ones.
All right.
So, let's see. That means I'm doing 1, 3, 5, 7. But it's saying use sigma notation, and I don't see any sigma notation written here, so I guess we've got to figure it out on our own.
Oh, I remember. You take that symbol, that Greek symbol, and you stick it in front, and on the bottom you always put 1. So we'll say whatever letter we want here. Let's go with K. K equals 1. And we're going all the way up until we've had 25 positive odd integers. So if I count 1, 3, 5, 7, all the way to the 25th one, we're going to get...
Well, I'm going to stop and do some work here for a second. All right, those are all the numbers I've got to get. Because if I did those out, and I counted, there would be 25 numbers there. So does that mean I'm going to go all the way up to 49 right here? No, because if I went 1 through 49, that would mean I'd have 49 different numbers. So I've got to figure out a formula right here that will generate odd numbers.
Oh. So really we're going to continue on by saying the 25 still goes on the top, but our function that goes to the right of that big symbol, or the big E, has to be some unique function, in that if I go from 1 plus something, I'm going to get 3. Well, 1 plus 2 is 3. Let's see if it works the next digit. 3 plus what is 5? 3 plus 2 is 5. So every time we're taking a value or a letter such as K and we're adding to it the number 2. So is it just K plus 2?
No, because look what you skipped. You skipped 2. So if I put 2 in there, 2 plus 2 would get me 4.
Oh.
All right, so obviously this is a little tricky one, but I figured I'd show it to you. You're going to see a better way to do it tomorrow. But if you remember, if you double any number, it always makes it even. So how am I going to get an odd number? Well, if I double that number and add 1, I will get an odd number. If I double a number and subtract 1, I will get an odd number. And you may be sitting here going, Mrs. Drillin, we'd never think of that. Well, this is common to the SAT. They love odd and even numbers. So you should know that doubling makes everything even. Then either adding 1 or minusing 1, you will get an odd number. All right, so if I chose this formula, 2k plus 1, if I put a 1 in there, 2 times 1 plus 1 gets me 3. That's not the first number, so I can't use that choice for an odd. I have to use 2k minus 1.
Because we know that 2 times 1 minus 1 is 1,
Whoops.
and that's where we started.
Yeah, so you may be thinking, I never think of that on my own. This is terrible. I hate math. Well, we're going to show you another shortcut tomorrow on how to do it. All right, so this would work if I do this. If I went from 1, and then if I put my last one in of 25, 2 times 25 is 50 minus 1, I get me my 49 up there.
So we know it's confirmed, it works, it checks.
All right, so let's start adding up. Let's do Gauss again. What's 1 plus, whoops, get over there, 49.
50!
And how many pairs of numbers are going to add up to 50? That's right, 12 and a half pairs, because half of 25 would give me 12 pairs, and there's one guy who doesn't pair up with anybody. So if we multiply that out real quick, 50 times 12.5 gets me
625.
woohoo! Okay, on the last one, we can use a calculator to find the sum of this finite sequence. So, Mr. Rude, who had to leave the room for a second, just gave me this handy-dandy calculator for my computer, and we're going to go through the steps. So here are the steps written out. All right, first thing we're going to do is press second function stat. So let's turn this calculator on, press second function stat. We're going to scroll over to math. And if you see down there, choice 5 says sum, because that's what we're doing. We're adding up. That's what the big E stood for, right? Let's point that out. Here we go. The big E right there means to add up, so that's why I chose sum. I'm going to go back, and I'm going to press second function stat again, but this time I'm only going to go over to OPS, which means operations, and I'm going to choose choice 5 there also. It's waiting now for me to enter my sequence. So now I'm going to tell the calculator, what does my sequence look like? Well, I just type in the formula, which is x squared plus x. Now, comma, because you have to tell the calculator what variable is it looking for. It's looking for the x variable. So now I'm going to type the letter x. And then I have these backwards. It's actually, let's change that, is actually supposed to be the lower bound followed by the upper bound. So the lower bound is, if we look at our sigma again, 3, and we want to sum up to the 10th term. Now notice that I have 2 sets of parentheses up here, so I must press 2 sets to close. All you have to do is press enter, and voila, 432. Thanks.